Sorry for that. So, technical issues. Okay, so right from again starting, I will explain. Refraction. Refraction phenomena. Refraction. So the path of the light ray changes when it is moving from one medium to another medium. Path of the light changes, or direction of the light changes, or the light ray deviate from its path when it is moving from one medium to another medium. So then we can say refraction. So I'm taking this is a rarer medium and denser medium. Speed of light is more in the rarer medium, speed of light is less in the denser medium. So example, air and water, and the second case, water and glass. Likewise examples we can take. See, in air and water, air is the rarer medium, water is the denser medium. In the water and glass, water is the rarer medium, glass is the denser medium. Okay, so now if the light ray is moving from rarer to denser. So I'm taking this a normal line. So light ray is changing its path, deviating its path. So emergent ray, so it will be in the glass slab. It will be the incident ray, so refracted ray and emergent ray. Here we can take emergent ray. Okay, so here we can consider emergent ray, but in these cases we'll consider incident ray, refracted ray, because rarer medium, denser medium. When it comes to glass slab, we will discuss all those points. Coming to glass slab. Okay, so now we can take, this is the incident ray, and refracted ray, So rarer to denser, it is moving from rarer to denser. Coming to the same, so if it is passing from denser to rarer, it moves away from the normal line. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. And here you can observe, angle between incident ray and normal line is called angle of incidence, and angle between refracted and normal line is called angle of refraction. So in this case, if you observe carefully in this case, so angle of incidence is greater than the angle of refraction, first point. So in this case, coming to the second point, okay, here angle of refraction is greater than the angle of incidence. Why? Sir, here you said angle of incidence is greater than the angle of refraction, but here you said angle of refraction is greater than the angle of incidence. Fully wrong, whatever you said. So you said here it is incident angle, so here you are saying refracted angle. Then how it is possible? Can you explain in detail? Yes, I will explain. Here you have to understand, as I mentioned earlier, if the light ray is passing from rarer to denser, it bends towards the normal line, right? So refracted angle is less compared to angle of incidence. And in the second case, refracted angle is greater than the angle of incidence. Why? As I mentioned, in the rarer medium, speed will be more compared to the compared to the denser medium. Yes or no? In denser medium, okay, speed will be less. When it is moving like this, suddenly if it is enter into the rarer medium, it moves away from the normal line. Here you can observe as it is coming like this, when enters into the rarer to denser, so it moves towards the normal line. Speed is decreasing. So here in this case, angle of incidence is greater than the angle of refraction. Here angle of refraction is greater than the angle of incidence. Okay, so this is about refraction. The path of the light changes when it is moving from one medium to another medium. So especially if it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay, so this is about refraction. Clear? So I hope it is very clear. Next. Now, if the light ray is passing, so I am taking here, this is a rarer medium, and this one is the denser medium. Okay, rarer medium and denser medium. Clear? Okay, done. So here I am taking the source. S means source, where light rays are coming from this point. So I am considering from here one light ray. I am taking the light ray here like this. Generally, if the light ray is moving from denser to rarer, what happens? If the light ray is moving from denser to rarer, it should move away from the normal line. Yes or no? It should move away from the normal line. That is a refraction. Yes. So here you can observe light ray is moving away from the normal line like this. Fine. Great. If same one more light ray I am taking like this, so here is normal line drawing. This is a normal line. Okay, this is the angle of incidence, and this one is angle of incidence and angle of refraction. Yes or no? So it is moving away from the normal line in the rarer medium. So at certain angle of incidence, generally if you are taking here like this, light I am considering like this. Okay, so normally this medium. So this is rarer and denser. So I am explaining about this one. So here you observe, I am keep on sending the light ray. So refraction takes place. It moves away from the normal line. 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 Again it moves away from the normal line. At a certain angle of incidence, the refracted ray passes or gauges or moves along the surface. Okay, so then that angle is called critical angle. The angle at which refracted ray passes or gauges along the surface. Refracted ray passes or gauges or moves along the surface. Okay, so once again you can observe here, at a certain angle of incidence, the refracted ray passes or gauges or moves along the surface. That angle is called critical angle. The angle at which refracted ray passes, gauges, moves along the surface. along the surface. That angle is called critical angle. This angle is called critical angle. The angle at which refracted ray passes or gauges or moves along the surface. That angle is called critical angle. So one more. So here I am taking away denser medium. Okay. So this is incident ray. This is a normal line. So the light ray is moving from denser to rarer. It makes more than 90 degrees. This is the angle of incidence. Angle of incidence. Here you can observe carefully. So refraction. First one is refraction. First one is refraction, general refraction. Critical angle and total internal reflection. Total internal reflection. Total internal reflection. Here total internal reflection. Total internal reflection. This is the rarer medium. Rarer medium, denser medium. Okay. So I hope it is very clear. Observe once again. So rarer medium, denser medium, incident ray, refracted ray. The light ray is passing from denser to rarer, it moves away from the normal line. If the light ray is passing from denser to rarer, the angle at which the refracted ray makes 90 degrees with the normal line, that angle is called critical angle. And here, the refracted ray, after refraction, it bends towards the same medium. Okay, or it makes more than critical angle. Critical angle means here the refracted ray makes 90 degrees with the normal line. So refracted ray make 90 degrees, more than that it is making. That's why. So it moving towards or bending towards the same medium. So this phenomena is called total internal reflection. Total light internally reflection takes place. So this phenomenon is called total internal reflection. Total internal reflection. I hope it is very clear. Right? Next. Now, so we will take glass slab. Okay, so we'll consider glass slab. So this is a glass slab. I'm taking like this. Okay, so incident ray, normal line, incident ray, normal line. So after that it will be refracted, and this will be the emergent ray. This is emergent ray. So here you can observe. So incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. So if you are extending this light ray, okay. So angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is the angle of refraction. Angle between emergent ray and normal line is angle of emergence. Okay, so the distance between emergent ray and extended incident ray or initial direction of the incident ray is called lateral shift. Lateral shift. Lateral shift. Lateral shift. Okay, so I hope it is very clear. Understood? Angle of incidence, angle of refraction, angle of emergence, and the distance between emergent ray and extended incident ray is called lateral shift. Coming to the vertical shift, so here I am taking the beaker. So I place the coin at the bottom of the beaker. This is a coin. So I am standing here. In this position, I can't able to see the coin. At position A. So after pouring water, the coin position rises up. So here, the coin position rises up. So here it is. This is the upper end position of the coin. This is the upper end position. Upper end position of the coin. Upper end position of the coin. And coming to here, actual position of the coin. This is the actual position of the coin. Actual position. So we can say coin actual position. So here, after pouring water, you can able to see the coin. So the distance between upper end position to actual position is called vertical shift. Vertical shift. I hope it is very clear. Understood? So once again, listen carefully. So incident ray, refracted ray, emergent ray. Angle between incident ray and normal in is called angle of incidence. Angle between refracted ray and normal in is called angle of refraction. Angle between emergent ray and normal in is called angle of emergence. And so the distance between emergent ray and extended incident ray or initial direction of the incident ray is called lateral shift. And so you are taking the beaker, so you place the coin at the bottom of the beaker from position A. You can't able to see the coin. After pouring water, the coin position rises up. This upper end position of the coin, this actual position of the coin. The distance between upper end position to actual position of the coin is called vertical shift. Okay, so I hope it is very clear. And so we can take a lemon also. So initially you can observe, so in front of the shops, if you go to Kirana shops, in front of the shop they'll place a lemon inside of the glass with water. Okay, so water filled in the glass, so in that lemon is placed. If you observe the position of the lemon, so it appears bigger. It appears bigger like this. Okay, so it is fully occupied with the glass. But if you take it out, it appears normal size, small size. But when it is placed inside of the glass with water, then it appears bigger due to refraction of light. And one more thing, a pencil placed in the beaker. So if you are taking the pencil, okay, so very important 3 marks questions. So listen carefully, observe carefully. So I place the pencil over here. So at the interference between air and water, the interference between air and water, the pencil position position of the pencil is bent. Okay, so actually the position must be like this, but it appears to be bent like here due to refraction of light. When you are observing here from here, so it appears like this. From upper end position, the pencil will come. So or from here, if you take like this, so it appears this position. Dotted lines represent upper end position of the pencil. But actually, so the actually this is the position, but it appears here. So somewhat bent. It appears to be bent, but actual position is here. Okay, so normally pencil won't be broken, it will be like straight. When you place in the water at that point of interference between air and water, it appears to be bent. This is actual position, but it appears to be bent in the water. I hope it is very clear. Okay, so at this position it appears like this. Okay, so if you place in the water, just example. Okay, so one is lemon, another one is coin, and the next one is pencil placed in the water. So these three examples are very, very important. Make sure that you are practicing all these questions. Next. Now we will discuss about lens. In the previous cases, so we discussed related to mirrors, concave mirror, convex mirror, ray rules and image formations, everything. Now we are discussing about lens, convex lens and concave lens. Convex lens and a concave lens. So now be ready. And here I'll give three questions. Which one is rarer medium, which one is denser medium, you can let me know. So these questions they will ask in the exam related to glass lab. So N1 is here and this is the N2. N1 is outside, N2 is refractive index. N1 is the refractive index. Okay. So okay, I'll explain. So N2 and N1, N2. Now if the light ray is passing like this, and the light ray is moving like this, and the light ray is, so dotted lines it should be represented. So in these cases, which one is greater? Can you let me know? So here N1 is equal to N2. In this case, N1 is greater than N2. Oh, sorry, refractive index is greater. So we are talking about refractive index. So N2, because its light ray is bending towards the normal line. So N2 is greater. In this case, so refracted is moving away from. So then N1 is greater than N2. So whatever the medium it is, suppose if you consider like this, so if the light ray is bending like this, you have to observe. So here you can observe if the light ray is passing along the normal line, so this medium refractive index is same. Whatever the medium it is, we are not talking about particular mediums. So if the light ray is passing like this, then we have to consider N1, N2 equal to same. And here you can observe in this case, refracted ray is moving towards the normal line. Refracted ray moving towards normal means n2 is greater than n1. Compared to n2, n2 is greater than n1. And in this case, if you observe, in n2, light ray is moving away from the normal line. If it is moving away means speed is more compared to n1, then automatically n1 is greater than n2. Okay, so likewise you have to observe. Okay, okay. Sir, what is refractive index? So I'll discuss about refractive index. Refractive index is nothing but, so light ray is moving from one medium to another medium. So I'm taking this normal line. This is a rarer medium, denser medium. This is a normal line. Normal line. Okay. So I'm taking the light ray like this. So angle of incidence and angle of refraction. First point is, so coming to the first one, incident ray, refracted ray, normal line lies in the same plane. Incident ray, refracted ray, normal line lies in the same plane. And coming to the next one, sine of angle of incidence to sine of angle of incidence to sine of angle of refraction equal to constant. That is nothing but n, refractive index. Okay. So if I am writing like this, n2 1, n2 by n1, or we can also write like this, n2 1, n2 by n1. Okay. So is equal to v1 by v2. Here also same, v1 by v2. Means inversely proportional. Refractive index n equal to by v. Speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. So in case n is inversely proportional to velocity, if you are considering like this, we can write. Okay. So n is n equal to speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. N is inversely proportional to velocity. So n2 1 equal to n2 by n1 equal to v1 by v2. n2 equal to n2 by n1 equal to v1 by v2. So same if we can take n1 2 or n1 2. So you can take n1 by n2 equal to v2 by v1. Okay. So I hope it is very clear. So this is about refractive index. This is about refractive index. Understood? So next one, coming to the lenses. So we'll discuss about lens. Now we are going to discuss about lens. So this is a part of this sphere, this is a part of this sphere if you are taking here. So this is optic center O, and this one I am taking, this is C1 and C2, and here is F1 and here is F2. So C1 we can also write 2F1, C2 we can also write 2F2. Okay, so we can take like this. You can observe here C1, C2, C1, F1, C2, F2. Convex lens. Convex lens is also known as converging lens. Convex lens also known as converging lens. Converging lens. Converging lens. And coming to the concave lens. Concave lens is also known as diverging lens. Okay, so here you can observe. Concave lens. Concave lens is also known as diverging lens. So check once concave lens. So this is the optic center. So I am taking this to C1, F1, C2, F2. So like this we are considering. So here you can observe This is a concave lens. Concave lens. Concave lens. Okay, so we'll discuss now ray rules. Ray rules of convex and convex. Ray rules of concave and convex lens. So here you can observe so optic center F1, 2F1, F2, 2F2. Now the light rays coming from infinity are parallel to the principal axis. After refraction, it passes parallel to, after refraction it passes through focus. Okay, so next one. First one, coming to the second one. Optic center F1, 2F1, F2, 2F2. Light rays passing through optic center, so like this. After refraction, it will become parallel to the principal axis. And coming to the third one, so optic center F1, 2F1, F2, 2F2. Light rays passing through optic center, like this. In the first case, light ray is parallel to the principal axis, after that passes through focus. In second case, if they passing through focus, after refraction become parallel to the principal axis. The light ray is passing through optic center, there won't be any deviation, so it passes like this. Okay, so next one, concave lens. Concave lens. Optic center F1, 2F1, F2, 2F2. If the light ray is parallel to the principal axis, after refraction, it moves. So that's the first one. Coming to the second one. So here you can observe optic center F1, 2F1 or C1, F2, 2f2 and C2. Light ray is passing through focus. After that, it will become parallel to the principal axis. And coming to third one, so light ray is okay. So here you can observe optic center f1, 2f1, f2, 2f2. If the light ray is passing through optic center, no deviation takes place. Okay. So concave lens. Concave lens. Now, image formations we'll discuss. Image formations. First one, optic center f1, 2f1, f2, 2f2. Okay. So you can observe here. Okay, done. Now you can observe here. So object is at infinity, image is forming at f2. How many light rays are required to form the image of the object? Minimum light rays. Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays. Yes, sir. Now minimum 2 light rays are required to form the image of the object. So I am taking one light ray like this, another light ray. After refraction, the light rays will meet at one point. Object is at infinity, image is forming at f2. Nature of the image, real and inverted, and size of the image is highly diminished. And coming to the second one, Optic center F1, 2F1, F2, 2F2. Object is placed beyond central curvature. Object is placed beyond central curvature. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object, I said. So I am taking one light ray like this. Okay. So you can observe here. Object is placed beyond F1. Image is forming between F2 and 2F2. Nature of the image is real and inverted. Nature of the image is real and inverted. Size of the image is diminished. Size of the image is diminished. Compared to the object, image size is decreased. Next one. Third one. Optic center F1, 2F1, F2, 2F2. Object is placed at 2F1. How many light rays? One light ray I am taking like this. After that passes through focus. So object is placed at 2F1. Image is forming at 2F2. Nature of the image is real and inverted. Size of the image is same size. Compared to the object, image size is same. Same size. Okay. These are the three image formations. The next one we'll discuss three more. So be ready for it. So 3 image formations. So fourth one, optic center F1, 2F1, F2, 2F2. Okay, object is placed between 2F1 and F1. So image will form beyond 2F2. One light I am taking like this, it passes through focus. So another light is passing through optic center. Object is placed between 2F1 and F1. Image is forming beyond 2F2. Nature of the image is real and inverted. And the size of the image is enlarged. Coming to the fifth one, F1 to F1 and F2 to F2. So object is placed at F. How many light rays are required to form the image of the object? Minimum 2 light rays. Okay, so one light ray I am taking like this. So after refraction passes through focus. Another light ray is passing through optic center. So object is at F1. Image is forming at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Highly enlarged. So image will be formed at infinity. Okay. So and then next one. Optic center F1 to F1, F2 to F2. Object is placed between F1 and O. One light I am taking like this. It passes through focus. Another light ray is passing through optic center. Okay. Object is placed between F1 and O. Image is forming same side of the object. So nature of the image is virtual erect and enlarged. Virtual erect is nature and enlarged image compared to the object, image size is increased. So this is about convex lens image formations and a concave lens. Coming to concave lens, image formations are there. Now we'll discuss about concave lens image formations. Concave lens image formations. Concave lens image formations. So I'm taking the concave lens like this. Optic center F1 to F1, F2 to F2. Okay. So object is placed infinity. One light I am taking like this, another light I am taking like this. So object is at infinity, image is forming at F1. Nature of the image is virtual, erect and highly diminished. Virtual, erect and highly diminished. Point number 1. Coming to the second one. Optic center F1 to F1, F2 to F2. Object is placed anywhere between here. One light ray I am taking like this, another light ray is passing. So the image will be here. Object is placed between infinity and optic center. Image is formed between F1 and O. F1 and O. Nature of the image is virtual, erect and diminished. Power of lens is reciprocal of focal length. Power of lens is nothing but reciprocal of focal length. So power of lens is nothing but reciprocal of focal length. Reciprocal of focal length. So P equal to 1 by F. SI unit of power of lens. SI unit of power of lens is diopter. Power of length is nothing but degree of converging or diverging of lengths achieved is known as power of lengths. Okay, so that is nothing but convex lens image formations. I hope it is very clear. So if you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Student the Brand. Thank you so much for joining and attending and listening my class. If you like the content, if you like the channel, please do like, share and subscribe to Student the Brand. So we'll see you in the next class. Signing off. Thank you.